Hello, grade 7s. This is going to be your lesson for 6.4. So in this unit, or in this section, we're going to be talking about solving equations using algebra. Okay, so I'm going to use some of the stuff that we've already talked about and just try to help apply it to try to further your understanding. So we're going to start with this question where we have 2n plus 3 equals 27. Okay? So some of you may look at it and you're already like, I know what the answer is. That's fine. Bear with me. I love that you can't interrupt me right now. So this is perfect. So what I'm going to do is I'm actually going to go back to what we previously had in our last section in 6.3 where we were talking about using the scale. So I'm going to do the same thing, but we have, in this example, two n's. So we have an n, and then an n, and then we have one known constant, which is 3. And then on the other side of the scale, it balances out at 27. So what's actually happening here? So similar to when we were using the integer tiles, I have a positive 3. I want to try to eliminate that positive 3. So what can I do? I can take this 27 and I can break it up into two different weights. One of them being the positive 3. So if I change this from one weight to two weights, one of them is going to be the 3. Okay? So then I have to go 27, I have to subtract 3, I end up getting 24. So my other weight is 24. Now, I can actually remove both of these 3's because I'm doing the same thing to both. Is the scale still going to be balanced? Yeah, I'm taking 3 from both sides. I'm taking it the same weight from both sides. It's still going to be the same. Okay? It's like if I have a bunch of fruit, I take an apple from this side and an apple from this side, the scale is still going to be balanced. I'm taking the same thing away. So once this is gone, now I have two weights that is equal to 24. Okay, from there I can actually go and I can try to calculate what the answer is. Okay, so I can say what is half of 24 or what times 2 equals 24. Okay, in this situation, I'm going to get n equals 12. Okay, so then I can double check it. I can say 2 times 12 is 24. 24 plus 3 equals 27. Okay, so that's just the first example. I can use the scale. You can use the scale as much as you want. If you find that it's not helpful for you or if you think it's a waste of time, that's up to you. But I still want you to be able, to understand exactly what's happening. And when we look at the scale, we can physically see we're removing 3 from both sides of the equation to try to calculate n's by themselves. That's our goal. We're trying to isolate the n's. We're trying to figure out what that missing weight is. All right? Now, if I move on, and I give you a different example, but this time I'm not going to be using the scale. Okay? Let's use an example of, where's the question? Here we go. I'll start with an easy one. So x minus 27 equals 35. All right, so what we're essentially doing is we are using opposite operations. Or I can ask myself, what plus or what minus 27, if I have something and I'm taking 27 away from it, what's going to give me 35? Now some of you might look at this and you're like, it's actually, those are big numbers, I don't like dealing with it. All right, well let's talk about, or let's think back to when we were using our integer tiles. Okay, when we were using our integer tiles, we actually had to say, we have negative 27, how can I get rid of it? I'm going to turn all of those 27s into 0 pairs. So what did I have to do? I had to put in positive positive 27. Okay, so all of those are now 0 pairs. Now I have to put in positive 27 on this side. Okay, so what's left? I've got negative 27 and positive 27. That's gone. Now all I have left is my x, and I'm trying to figure out what my x equals. So I add these together, and I end up getting 62. Okay, once I 5 plus 7 is 12. I carry my 1. 1 plus 3 plus 2 is 6. So my answer there is 62. Okay, I'm using the opposite operations. Okay, another way that I can do that, okay, to try to eliminate a step is instead of saying I'm going to add 27 to this side, I'm going to bring this over. Oops, sorry, like this. I'm going to bring this over to this side, and then it's going to become its opposite operation. It's doing the same thing. Okay? The only thing I'm not seeing is that I'm making the 0 pairs here, but I'm seeing the plus 27 on the opposite side. So it ends up working the exact same way. One just looks a lot shorter. Okay? I'm going to give you one that's a little bit more challenging, and feel free to pause once you see the question. Try it out on your own. Okay? This next one is going to be 11x equals 132. Okay? We don't have any addition. We don't have any subtraction. Okay, so what do we have to do? We have to figure out what can we times 11 by to get to 132. In this situation, we are going to have to divide. We're doing the opposite operation once again. So we divide both sides by 11. Okay? The opposite of multiplication, 11 times x, is division. So we divide these. They're gone. Okay? Now we just have this side. So we end up getting x equals 12 in this situation. Okay? Now, let's combine them. So we're going to have one with addition and one with multiplication. So we're going to go 4x plus 7 equals 35. It looks complicated. We just got to take it one step at a time. When we are doing expressions and equations, we actually do the reverse of order of operations. We're going to start at the bottom. So now it's SAMDAP or SADMAP, okay? Instead of BEMDAS or PEMDAS or BEDMAS. Okay, so we're starting with the addition and subtraction. But we have to eliminate this first. So we have positive 7. What's the opposite of positive 7? Negative 7. Which means we have to subtract 7 on this side as well. Okay? So once we subtract, this is gone. Our next step is we have 4x is going to equal 28. Okay? Now, I have 4 times a number equals 28. I have to ask myself, what times 4 is going to equal 28? Well, I can divide both sides by 4. 4 divided by 4 is 1, so that's gone. All I'm left with now is 1x. Okay? 28 divided by 4, or how many times can 4 go into 28? I end up getting 7. Well, let's see if that works. I have 4 times 7. 4 times 7 is 28. Plus 7. 28 plus 7 is 35. That works out. Okay. So, one area that a lot of people, I'm going to see people struggle with, is they're not going to quite remember to do the correct steps. Okay, so if we try to simplify it even more, if we have x minus 6 equals 9. Okay, x minus 6 equals 9. In this situation, I need to do the opposite operation. I'm trying to get my variable, my letter, by itself every single time. So that's my goal in every single one of these questions, because I want to get it by itself. So I have x minus 6. I don't want x minus 6. I just want x. So what's the opposite thing that I have to do? I'm going to create those 0 pairs. I'm going to add 6. So then I add 6 to the other side. I end up getting x to equal 15. Okay, so 15 minus 6 equals 9. That makes sense. All right? I'll start off with another question. And like I said, feel free to pause these anytime, and you can check your answer with me after. Okay? If I have 3x minus 2 equals 7. Okay? I need to go, same thing. I'm going to start with my addition and subtraction. I'm going to start with the easy stuff in this situation. Okay? So I have negative 2. I need to find the opposite operation, which is positive 2. So I'm going to add 2 to both sides. Now I have 3x equals 9. Now I have to ask myself, do I want to know what 3x is, or do I know what 1x is? I'm looking for what 1x equals. Okay? What do I put there to make it work? So I'm going to divide both sides by 3. Okay? 3 divided by 3 is 1. Now I have 1x remaining. That's what I'm looking for. 9 divided by 3, or how many times can 3 go into 9, gives me 3. Okay, let's double check. 3 times 3 is 9. 9 minus 2 equals 7. Okay, so my answer works out again. Okay. I'll give you one more example to let you pause it. And this one I'm going to make just a little bit harder, just so that I know that everyone is understanding properly. If you have any questions, once again, you can send me an email, and then you can look through all the answers as well. Okay? So here we have, let's go with 13n plus, let's go plus 5 equals, let's go like this. Okay. So I'm creating kind of two possible equations on both sides. I have a variable with a constant, and then here I have two constants being added together. So I can simplify that right away. So what am I going to do? I'm going to add those together. Okay? Or what I can do is I can try to balance it out. If I've got 3 and I've got 5, and I'm going to end up taking 5 away, so I'm going to have negative 5. Can I just change this number and move 2 over? Well, why not? Okay? So this is going to end up, if I take 2 away, I'm going to have 78. Okay? And then that step is done. Because this is going to be gone, and then I'm going to have 2 from here that are going to be gone as well. And 3 plus 2 is 5. So now I'm going to have 13n equals 78. Okay? Now I need to actually go about dividing it. Okay? Divided by 13 gives me 1n. So I divide this by 13, and n ends up equaling 6. Okay? That's not what I expected you to do in your head. That's why it took me a little bit longer to actually come up with a question, because I was doing it in my head. But 13 times 6, well, 10 times 6 is 60. 6 times 3 is 18. 60 plus 18 is 78. Okay? 78 plus 5 equals 83. Okay? Which is what this ended up equaling, 80 plus 3. Alright? Anyways, I'm going to give you time to work on your math makes sense. Section 6.4. Also make sure that you complete the Google form. As usual, it's just going to be a couple questions. Don't stress about if you get them wrong. Maybe do your math makes sense first for some extra practice. I'm not taking them in for marks, as you know, but they're more just for completion. All right, email me if you have any questions.